The effects that agricultural systems can have on natural ecosystems can range greatly, from mild to severe depending on both environmental conditions, rainfall, wind, topography, wildlife, and other natural forces. The intensity of the agricultural systems being practiced is also another major factor in soil's conditions and affect some of their characteristics. In this study, we will be comparing soil characteristics found with natural untouched oak savanna and abandoned walnut orchard, both located in Bidwell Park.
We collected atmospheric conditions and soil characteristics at all 4 locations. The 2 Bidwell Park locations were taken on September 11th, and the Chico State Farm locations on September 18th for a comparative analysis. The natural oak savanna was untouched, and the vegetation is what is expected. The savanna floor was covered with small plants and debris of organic material from the canopy and other plants. The abandoned orchard did not have a complete return to its natural state. There were still a few walnut trees living, and the oak trees were approximately 8 meters high and sparse. The floor of the abandoned orchard was not covered as dense as the natural oak savanna. The 2 locations at the Chico State Farm were both typical of production pasture and walnut orchard. The pasture consisted of short grasses with a variety of depressions caused by grazing cattle. In the orchard, the soil was bare and exposed except for the shade of the trees. The atmospheric readings consisted of air temperature, relative humidity, dew point, wind speed, and light intensity. All measurements were taken at 1.5 meters above the ground. Soil characteristics consisted of soil temperature, soil compaction, pH, color, texture, structure, and bulk density.
The air temperature and wind data was collected using the Kestrel 3000 pocket and weather meter. Dew point and relative humidity were also collected, but were added to and averaged with a dry-wet bulb psychrometer. Light intensity was measured by taking several readings in a 3-meter circle consisting of both shade and light. This number was averaged from the readings. Soil temperature was measured by driving a stake 15 centimeters into the ground and measuring the temperature. A Dickey-John soil compaction tester was used to determine soil compaction. The compaction tester was used 3 times in a 3-meter circle, and the result was from the average. A soil sample was taken and mixed with deionized water until it was in a slurry, and then a digital pH meter was used to measure pH values. Soil color was determined using the Munsell color code used by the National Resources Conservation Service. Soil texture was also determined by using the fill technique used by the NRCS. Soil aggregate stability was measured by placing a small pad of soil in a dish with water. The dish was then moved to determine if the soil aggregates would break down or not. Soil bulk density was determined by using a water volumetric technique to get a proper volume. Once removed, the soil was dried to obtain a dry mineral weight, which was used to calculate bulk density.
Our results for soil compaction can be illustrated by Figure 1, which shows the abandoned walnut orchard having the highest soil compaction and the conventional walnut pasture being the second highest, and oak savanna being the lowest. Table 1 characteristics show us the pH consists around 6.5 except for the walnut orchard being around 10-fold to 7.5. Figure 2 shows us bulk density, where conventional walnut orchard has the highest density at 1.88, and then organic pasture having a bulk density at 1.71, then the abandoned walnut orchard being at 1.52. The last is oak savanna being the lowest at 1.4. The organic pasture and abandoned walnut have the least bulk density than the organic pasture and the conventional walnut orchard. Table 3 indicates there were no major differences during the testing on weather conditions, with the one exception of light intensity in the organic pastures due to the fact there were no trees.
As the results showed, the organic pasture and conventional walnut orchard had the highest compaction and soil bulk density numbers. This study also showed that the abandoned orchard is slowly returning to a more natural state with better soil characteristics. There are many factors that contribute to each location's specific characteristics,
but the most overwhelming factor is the presence of intensive agricultural practices. The untouched oak savanna had the lightest compaction and the lowest bulk density numbers. The pH was also optimal and there was a broad diversity of vegetation. The soil was a light, loose soil that was able to retain such stability and is an indication of good microbial activity. The abandoned walnut orchard in Bidwell Park had many similarities to the natural savanna. The major difference was the size of mature trees and the species of trees. The conventional agricultural production system showed a difference in soil characteristics. Most notable was the higher compaction and bulk density results. Both of these factors limit plant diversity, microbial activity, aggregate stability, and the overall soil quality. The walnut orchard has no ground cover and is exposed to rain and wind erosion, along with sustained traffic from large agricultural machinery. This accounts for a denser soil with less soil organic matter. It is important that we understand that both environments are very important. We should look to see if there are ways to integrate natural soil practices into conventional agricultural production. This study showed the difference in soils on the visually and structural level. A full chemical diagnosis of all 17 essential nutrients should have been implemented as well. This study showed that conventional agriculture can be detrimental to soil quality and that new techniques should be explored to develop a more sustainable long-term cropping system.